which roller coaster is steepest? I think if we look at these, we'd all agree that roller coaster 1 is going to be steeper than 2, and 3 would be the least steep. But how can we get a number that reflects this? Number 1 isn't as tall as coaster 2, though it's certainly, both of them are taller than coaster 3. And number 1 is the one with the shortest distance along the ground, but that doesn't necessarily mean it's the steepest one. And we have two numbers we need to think about here. The height of the roller coaster is called the rise, and the length of the roller coaster, horizontally, is called the run. And the slope, or the gradient, two different words for the same thing, is the rise divided by the run. If I do that calculation for the 3 roller coasters, then coaster 1 is 225 divided by 75 for rise divided by run, which is 3. Coaster 2 is 300 divided by 300, which is a slope of 1. And coaster 3 is 100 divided by 250, which gives me 2/5, or 0.4. Far less steep than coaster 2, let alone coaster 1. So this number gives us a number that makes sense for slope, or gradient, or steepness. It doesn't actually matter where we measure the rise and the run, so long as we measure the rise and the run, and the calculation is still rise divided by run. Now, I can imagine making a smaller roller coaster than 2, and if I make its height half as big and its length half as big, then its slope, coaster 2A, will be 150 divided by 150, will still be 1. And the slope of a straight line doesn't change. I could make it half as big again, a quarter the size of the original. And here I have a roller coaster with the same short run as coaster 1, but a much smaller rise, so its slope is much less. Finally, we might look at these. So that coaster has its slope of 75 divided by 75 is 1, the same as the original coaster 2. Finally, we might look at this on an XY graph, in which case our rise would be the change in Y and our run would be the change in X. So if I'm asked to measure the slope of this line on an XY graph, then I need to measure the rise and the run. Here, between A and B, I have a rise of 5 and a run of 5, and that means that the slope will be 5 divided by 5 is 1. I can also think about the slope as being how far up I go if I go along 1, and we can see this here. Now I can count between any points here. I can start at A, go up 5 and go along 5 to B. I could start here at 2, 2 and go up 1 and along 1. I could start here or here, anywhere on this line if I go. I'm just trying to find 2 points that meet grid lines on this line and find out how far I go up if I go along 1. So my slope is 1. If I were to move this point along here, I still have a rise of 4 and a run of 1, and the slope is still, now it's 4 over 4, but it's still 1. Doesn't matter where I measure the slope. Now let's see what happens if I change this over here and make this half as steep. Here we can think of the rise as being 2 and the run as being 4. Or we can say, let's find anywhere on this line, and if I go up 1, I go along 2. If I was to go along just 1, I would only be going up, well, half. It's difficult to tell, so it's better to use grid lines, but this will give me a slope of a half. If I were to move this point all the way over here, and then now I have a rise of 8 for a run of 2, and I'm going to get a slope of 4. If I can do this down here just as well. And my simplified slope Where else can I take point B? Well, what about if I take point B to be somewhere on this x-axis? Well, then my rise is 0 and my run is 4 and my slope will just be 0. I don't need to go along 4, I can go along just 1 anywhere I like on this line, and I can see that the slope is 0. And if I were to move this point down, now my rise is negative. My change in y is negative as I change x. So my slope will be minus 4 over 4, or minus 1 over 1. It'll be minus 1. I can measure it anywhere on the line. Just pick a point on the grid, and if I go across 1, I have to go down 1, and we have to measure where the slope is. So let me put in a few and see if you can tell me what the slope is. What's the slope here? Pause the video and then we'll check. 3, 2, 1, and the slope is 2 over 4, or 1/2. I can go up 1 and along 2. So here I have a rise of 1 and a run of 2. Here I have a rise of 2 and a run of 4. How about this one? Pause the video. 3, 2, 1, and here we have a rise of 2 and a run of 6, giving us a slope of 1/3. Let's try another. See if you can work out. 3, 2, 1. Well, here we have a rise of 6 and a run of 2, or a rise of 3 and a run of 1. I can measure that anywhere I like on this, but best to use grid points somewhere. And another. Then let's see how you do with this. 3, 2, 1. And here the rise is minus 2 and the run is 3, so the slope will be minus 2/3. It's a bit less than a slope of 1. A slope of 1 will go diagonally, or minus 1 in this case, plus 1 in that case. So a fraction would be a bit less than a slope of 1, and we'll try one more. Let's try that. 3, 2, 1. And here we have a rise of minus 5 and a run of 2. So our slope is minus 5 over 2, or minus 2.5. So I could, there's no simpler way of doing that really. And finally, this slope here, 3, 2, 1. A rise of 0 and a run of 4 gives me a slope of 0. Now here's a challenge for you. What about this sort of line here? What's the rise and the run here? 3, 2, 1. Well, the rise is 5 and the run is 0. So we get 1 over 0 and we say the slope is undefined. We don't have to do these going through the origin. We could have them anywhere else. We can move them over here. There's a slope of 1. So let's try one more for you. What's the slope here? 3, 2, 1. Well, the rise is 6 and the run is 3. So the slope is 2. I go for every 1 along, I go up 2. We can measure that anywhere we like on the line, but it's best to do it at a grid point rather than at some random point like this, which is in the middle of nowhere. Let's go for a grid point and we can see 2 over 1 is 2. So let's have a quick check that we can understand what sort of slopes we have with this line here. How would you describe the slope? Pause the video, give an answer, then check mine. 3, 2, 1. I think this is 0, and that is correct. How about this one? 3, 2, 1. I think this is negative. And this one, 3, 2, 1. I think this is positive. And this one, 3, 2, 1. I think this is undefined. We're going to have to divide by 0. So if I'm asked to make a slope, a line of a slope of a half, then I want my rise to be half of the run. Here my run is 1, 2, 3, 4, 5, 6. So I really want to go up 1, 2, 3. And we can check that with this. Here we have 1, 2, 3, 4, 5, 6. And here we have 1, 2, 3. So that is correct. Here we want a slope of minus 7/4. So we want our run to be 1, 2, 3, 4. Let's move this over here. 1, 2, 3, 4. But we want our rise to be minus 1, 2, 3, 4, 5, 6, 7. Let's just check that, and I believe that's correct. A slope of 2. Then for a run of 1, we want a rise of 2. That will do. Or for a run of 2, we want a rise of 4. That will equally do. Either of those will do. Or have I got that right? 1, 2, 1, 2, 3, 4. Yes, I think that's correct. And 3/5. Then I want to go along 5. 1, 2, 3, 4, 5, and up 1, 2, 3. Or I could go along 10 and up 6, which would take me to this point here. Either of those will do. 1, 2, 3, 4, 5 more, and another 1, 2, 3 along here, and that would be correct, 2. And this problem asked me for a slope of 5 over 2, so I go along 2 and up 1, 2, 3, 4, 5, which is a slope of 2.5 along 1 and up 2.5, and I think that's correct. And a slope of -1, well, that would be along 1 and down 1, or along 2 and down 2, or along 3 and down 3, or 4 and 4, 5 and 5. Any of these would do. This would give me a slope of -1. So if I'm asked to work out the slope from a graph, then I need to follow this process. I need to work out the rise and the run, and this has given me nicely 2 points that are on grid lines, so we're not dealing with weird places like this that aren't quite right. And I need to find the rise and the run, and the rise is a negative number, 1, 2, 3, 4, 5, and the run is along 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think the slope is -5 ninths. Let's double check. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 6, 7, 8, 9. And let's check. -5 ninths. And here again we have a negative rise. It's going down 2, and the run is 1, 2, 3, 4, 5. So that is -2/5. My way of thinking, or -0.4, and we can check that. Let's try another one, and here we have a positive rise of 2. And a run of 1, 2, 3, 4. So 2 over 4, I reckon, is the same as 1 over 2. So I'm going to go for that. We can check that there. And that gives me a slope of 1/2. Here, my rise is 1, 2, 3, 4. And my run is 2. So I think 4 divided by 2 will give me a slope of 2. And this is quite clearly a rise of 0 over any run that I choose, so the slope is 0. And here, my rise, 1, 2, 3, 4, 5, 6, 7, 8, and my run, 1, 2, 3, 4, 5. Let's just see that clearly. And therefore I think this is a slope of 8 over 5, which I could also write as 1.6. And let's check that. Yes, indeed.